Oh, hi. Hang on a sec. Welcome to my Replica Telegraph office. This is a copy of a small telegraph office from the late 19th century and early 20th century. And if this had been at Days of Yore in Didsbury, it would have been connected to a live telegraph wire that ran from the Victorian Society of Alberta encampment over to the Yankee Valley Yankees. But since we're not at Didsbury for Days of Yore this year, I'm going to do a little digital presentation for you on telegraph, how it worked, a little bit of its history, and why we call it the Victorian Internet. Let's get started, shall we? Why Victorian Internet? By Victorian Internet, we mean the fast, long-distance communications which became available to almost everyone for a price during the Victorian era. For the first time, governments, businesses, journalists, scientists, and ordinary people could send and receive messages almost instantaneously, across sometimes vast distances. Prior to the invention of the telegraph, the fastest way to send any significant message was by a letter, carried by a courier on a horse if by land, or a ship across the sea, with no guarantee it would ever arrive. The effect of such immediate communication on Victorian society was in many ways greater than the effect of the modern internet on ours. Initially, the largest impact was on business and finance. Companies could keep in touch with distant offices, suppliers, and investors, and stock markets could keep track of business activities, speculate on the availability of commodities. Politics began to move at a much faster pace, as governments could keep track of what was happening inside their borders and receive intelligence about what foreign competitors were up to. For the first time, the news became something more than local hearsay and political pamphleteering. Companies sprang up to collect interesting stories and information from abroad, transmit them by the telegraph to their head office, and then supply those stories to newspapers, for a healthy fee, of course. Some papers, like the Times, and press agencies like Reuters, which was one of the first of these, are still in operation today. A good example of the speed that the Victorian Internet provided for the passing of information is the explosion of the Krakatoa volcano in August of 1883. The volcano was an island located in the Sunda Strait between Java and Sumatra in Indonesia. At the time, to travel from London to Sumatra took several months by ship. News of the eruption reached London via the telegraph, while the atmospheric shock waves from the explosion were still echoing around the world. Nothing like this enormous increase in information distribution had ever happened before. What does telegraph mean? The word is made up of two parts. Tele, from Latin, which means distant, and graph, from the Greek, which means to write. Originally, the term was used to describe systems that we would call today semaphores. These use visual signals like flags, lanterns, or swinging arms mounted on towers. Napoleon had such a telegraph system that linked major cities in France to Paris, for example. Flag systems are still used today by sailors and Boy Scouts. The Electromagnetic Telegraph. The discovery and quantification of electrical phenomena, especially electromagnetism by the American Joseph Henry in the 1820s, brought the possibility of signaling across long distances. Many different systems were developed in England and on the continent, but most of these were complex, only worked across relatively short distances, and were never widely adopted. These systems became known as electromagnetic telegraphs, to distinguish them from the visual telegraphs. In the late 1830s and early 1840s, an artist working in New York by the name of Samuel F. B. Morse developed a version of the electromagnetic telegraph along with his co-inventor Alfred Vail. After much experimentation, Morse convinced the American government to fund a demonstration line between the Capitol building in Washington, D.C. and Baltimore, Maryland. The line first began operation on May 24, 1844, with the sending of the now famous message, "What hath God wrought?" This was not the first message ever sent, however. There have been several shorter range demonstrations for various government officials, and much like kids with walkie-talkies, there was a bunch of "can you hear me now" kind of messages. Here are some of the recorded ones, ranging from very detailed to obscure. Successful experiment with telegraph, September 4th, 1837. A patient writer is no loser. Attention the universe by kingdom's right wheel. They even got political. In 1843, during a demonstration at the Capitol in Washington, a committeeman who was familiar with the latest telegraphic code and opposed to President Tyler tried it out by sending these words: "Tyler deserves to be hanged." The Morse Electromagnetic Telegraph eventually became known simply as the telegraph, as it superseded all other forms of long-distance communication around the world and became the basis for the Victorian Internet. So how does it work? What distinguished the Morse Vail telegraph from its competitors was its simplicity. A telegraph is what's known as a series-based continuous current circuit. Electric current is always flowing through the wire. The current was supplied by chemical batteries that work best while continuously supplying that power. The current energizes an electromagnet in a telegraph instrument called a sounder. Pulling down a steel armature, this makes a click sound. When the current is interrupted, the electromagnet de-energizes and a spring snaps the armature up, making a clack sound. The telegraph key acts like a switch in the circuit. The key opens and closes the circuit, thus causing the electromagnets to energize and de-energize, making a series of click-clacks that make up the code. All the keys and sounders of a telegraph line are in series. This means that any key that opens the circuit will cause all the sounders to de-energize and clack. When the key is closed, they all energize and click. Because the keys interrupt the circuit when open, each key has a circuit closer switch that is always closed except when sending, so the circuit can pass the signal down the line. Like all electric circuits, there must be a source of voltage and current that flows from one pole of the battery through the load, the sounder, to the other pole of the battery. And in most circuits, this would require two wires, one coming from the battery and one going back to the battery. Telegraph circuits only have one wire. The return circuit uses the earth itself. This was discovered almost by accident when an experimenter in Europe tried to use railroad tracks as the wiring for a signal system. One rail for each side of the circuit. But it wouldn't work because the rails were in contact with the ground and shorted it out. Over short distances, the earth is a relatively poor conductor, but over long distances, like several to hundreds of miles or more, the earth can conduct electricity so well that the resistance is actually less than that of the wire. This means a great savings in cost because of only a single wire was needed. Since what determines the strength of an electromagnet, like in the sounders, is the current, not the voltage, everything was regulated to supply a standard current to the instruments. Typical telegraph systems used around 160 to 200 volts DC, but the current was only around 40 milliamps. This surprisingly simple system can carry the click-clacks over hundreds of miles.
Here's my Replica Telegraph office again. Most of this should be familiar to you by now, but I'll just go through and pick up some of the details for you. Here's the sounder that was in the discussion of how things worked. This one is called a local sounder. It had its own little battery, and again, when the circuit is energized, it clicks, and when it's de-energized, it makes kind of clack sound. So when you are sending signals. Here's the telegraph key. This is a typical telegraph key from the latter part of the 19th century, and it was exactly the same kind of key that was used right up until the 1960s. It's called a straight key. You can see that it has a little knob here that you use to push, and it will activate the circuit, make a click and a clack. It has a circuit closer switch on the side, which closes the circuit. You can hear it do the click. And when I want, then anybody sending would come through. When I want to send, I open the circuit and then I can send. Now, something I didn't talk about is the relay. And the relay was used to interface the local sounder with the main line. It has slightly larger electromagnets, and the high voltage but low current from the main line would come in on the left-hand side there. and it would make the connection by pulling on that little bar, and when it does, it opens up a local battery, which is low voltage but relatively high current, to run the sounder. This device is a kind of sounder. It's known as a mainline sounder, and it was wired in such a way that it would operate at the high voltage but low current of the main line. It was often put up on the windowsill, especially if it was a train station, and the operator was out working on the platform. He could hear if a signal was coming through, and it was wired in such a way that even if his local equipment was disconnected from the line, he could still hear a signal coming through and then go back in and connect it.
The code. Morse's original code consisted of a series of pulses that represented simple numbers. The numbers referenced entries in a code book. The recipient used the book to reconstruct the message. This was a clumsy system to work with and required a very complex table of code words to make up any given message. Realizing this, he and Vail determined that a true alphabetic code would be more flexible and created a set of patterns, one for each letter of the alphabet, plus numbers and punctuation. Each letter was designated with a pattern of dots and dashes. Dots were rapid click-clacks of the circuit being closed and opened by the key. Dashes were the same, but there was a pause between the closing, the click, and the opening, the clack. Technically, a dash is twice as long as a dot, and a space between letters was 3 times as long. The pattern of dots and dashes. Rather than simply starting at A and going to Z with a regular pattern, Morse looked at the distribution of letters in typical written English and settled on shorter codes for more frequently used letters. The shortest Morse codes are a single dot for an E and a single dash for T. These are the most frequently used letters, and he determined this by counting the type in the trays a printer uses when setting out a newspaper page. International Morse code. When the telegraph was adopted by European countries, the English alphabet was problematic for languages like German, so a new continental code was developed that is slightly different than the original Morse code. The original code is now known as American Morse code and was used by railroads right up to the 1960s. Once wireless telegraphy, that is radio, became available in the 1990s, which used beeps instead of clicks and clacks, it was found that the continental code was easier to send and read than the American Morse, so that became the official radio communication code and is now known as International Morse code. The famous SOS, first used by the Titanic radio operators in 1912, is in the International code. The S is the same in both, 3 dots, but the O is different. In International Morse, it is 3 dashes. In American Morse, it is 2 dots with a space between. Canadian Telegraphy. The history of the telegraph in Canada is intimately tied up with the railroads. As the plans for the Canadian Pacific Railroad were being made, it was determined that a telegraph line would be needed to help coordinate the construction. This line, known as the Dominion Telegraph, would run west from Fort Garry, now Winnipeg, following the proposed route of the railroad across what is now Saskatchewan to near Edmonton, then through the Rockies via the Yellowhead Pass to connect up to the private Western Union lines that had reached the area of Kamloops from Washington State by then. The line was constructed in fits and starts between 1874 and 1877 and eventually reached Leduc, south of Fort Edmonton. The route of the railway was changed to go through Rogers Pass in 1882, so the northern route was not used, and the telegraph line was never completed to Kamloops. However, the government-owned Dominion Telegraph had been instrumental in the settlement of the prairies and had proved itself invaluable during the Northwest Rebellion in 1885. The line didn't work very well on the whole, as it suffered from several big difficulties related to its remoteness and the simple, that is cheap, construction. It worked pretty well in the winter, but the rest of the year was problematic. For one thing, the area just west of Fort Garry is very marshy, so when the ground thawed in the spring, the poles tended to fall over. Out on the prairies, poles were hard to come by, so poplar was used, which was prone to rot, and the buffalo loved to use them as scratching posts, knocking them over. Frequent gas fires also burned the poles down. Still, the telegraph was an important means of communication back east from the developing communities out west. One interesting story concerns the operator at Battleford, a main station on the Dominion Telegraph. This operator was responsible for coordinating traffic on the line, both east and west. The problem, when the line was working, of course, was that it was hard to coordinate the regular check-ins that would help to determine how it was working. This was before Sir Sandford Fleming's development of standard time in 1879. So this operator decided that he would supply the time standard. He built an accurate sundial outside his office, and every day at his local noon, he would send out a message indicating that on the wire. All the stations along the wire would then adjust their clocks to match. And that way, if the check-ins were to be done at a particular time, everyone would be on the same time. The original, at the beginning of the long dash, the time will be exactly 11 o'clock. Thanks for watching. That's all the time we have. I have to start practicing for the Heritage Park Morse Telegraphy Club, which I'm a member of. On the weekends during the summer and Saturdays, we do live telegraphing between the train stations in the park. If you're interested, come check it out. Also, I'm really looking forward to seeing all of you live at Didsbury on Days of Yore for 2022, and hope you enjoy the rest of this virtual Days of Yore. Thanks for watching.